everybody. So the next thing we're going to do, we're starting a new chapter somewhat, but this is an extension of Gregor Mendel. Mendel had this idea that genes come in two variations, a dominant and recessive, but that's not always the case. There's always these exceptions to the rules. So the basis for what we just finished is going to be what's going to help you understand this next topic. If you really truly didn't understand the first half, this is going to be a lot more difficult to take it to the next level. There are three different topics we're going to cover today. It's incomplete dominance, codominance, and multiple alleles. So the first one, and for all of these, you'll see they run into a pattern. So the first one, incomplete dominance. I apologize, some classes got a packet and others I forgot to pass it out. So if you just want to write what I have down, then kind of transfer it to the pack when you get it tomorrow. Incomplete dominance is when you still have one gene. We're used to the fact that there's one gene, such as earlobe attachment. There's a dominant form and a recessive form, but in incomplete dominance, there is no such thing as dominant and recessive. So both alleles technically have the same power, if you will. Understand this power. It's not that one can dominate or mask the presence of another. Instead, when they are both present at the same time, there is a blending of the alleles, and therefore the blending of the phenotypes. So we don't have the same notation. Every one of these has a different notation, which is the most important thing. Can I identify a problem that's incomplete dominance, and then how do I notate it to someone in their genotype? So for example, some very common examples you would see is something like a flower. So they have options where you have, change the color, a red flower, a pink flower, and unfortunately the third color is white, and if I write white you won't be able to see it. So I have to go with black. But I'm still going to write it white flower. So the first thing with incomplete dominance is you have to look for what are the extreme colors, because there's one that's a blend and two that are the extremes. In this case, you notice this is the first time where three phenotypes are seen. Red, pink, and white. We never had that. We either had a unattached earlobe or attached earlobe, widow's peak or not widow's peak. You can do this or you can't do that. There's never been a third variation. So when you see three variations, you know something's going on here. And when you see that the third variation is a blending of the two, can you see how pink is the effect of red and white blended together? That's exactly what's happening here. So this is the blended effect. You only get blending if you have two different alleles, so that's the heterozygous state. So if you're a red flower, you're in the homozygous state because you only have the red allele. It doesn't blend. When you get two reds together, you still get red color. When you get white with another white, it still blends as white. When it blends with the extreme colors, you get the pink flower. I'll give you some other examples, but to notate this, they don't give red a dominant letter and white a recessive because that's not the case. They're both equally as powerful. So I've seen a few different notations. If you're viewing this with a different teacher, or if you're just some random person that came across this, I don't know the notation that your teacher will give you. I generally do this, which is very common. You will give an uppercase or capital letter to one extreme. You will give another capital letter to the second extreme. So they both get their own letters because they're both of equal power. So therefore, the pink flower is a combination of these two. So I'm going to go right into the genotypes. For a pink flower, you would have to have the red allele and the white allele to express the blending. In order to be red, you have to have the homozygous state. So I never would say a homozygous red flower. It is insinuated that the red flower has to be the homozygous state because that's the only allele combination that it could be to be the red flower. Then on the flip side, the white flower would have to have the homozygous state for the second allele. These are the only three combinations you can have. Each combination gives you a different blending. And for another example, if you had black, white, and gray, guess which one is the blending? The gray. So you come up with your own notation for the black would get its own allele, the white would get its own allele. So you would do something like black would be the big B, the white would be big W, the gray, which is the blending, would be big W, big B, big W. Just another variation. So if I had to cross or do a Punnett square with this, and I said cross 2 pink flowers, I automatically know pink would be RW, so I'm crossing 2 RWs. The Punnett square is still the same. It's the notation that is the most important thing. So you would cross that, looks slightly different from a normal monohybrid cross. The interpretation of this genotypically is a 1 to 2 to 1. Phenotypically, it's 1 red to 2 pink to 1 white. So think of other examples that could be incomplete dominance. Hair texture, straight, wavy, and completely curly. That's another example of incomplete dominance. And I'll throw another few at you, but you have to be able to recognize it. My suggestion, you're looking for 3 variations, and where you can see one is kind of an intermediate between the 2 extremes. So that's incomplete dominance. You're going to be doing some work tomorrow in class with that. The second one, codominance or a codominant inheritance. For this one, you kind of get 3 phenotypes, but they're slightly different. So what you'll get is still, it's 1 gene, neither is more powerful, so you're not going to get one masking another because they're both dominant. But how is that different than incomplete dominance? There is no blending. Instead, they both show through. If you have the allele, if you have the allele for both of them, you'll express both independent of one another. So, for example, what are some common examples? I've seen one with horses. It's a very common one you see in textbooks, where there is a reddish horse, there is a roan horse, which is another color, and a white horse. I can't say it's always the best one because roan is not a blending of the colors here. Roan is actually having red hairs and white hairs. But from a distance, you really can't see that. But if you get up close and pull a hair off, you would. Examples that you can see, imagine if hair texture wasn't actually incomplete dominance, it was codominant. If someone had a straight allele and a curly allele, picture what their head would look like. It wouldn't be a wavy. It would be that if some hair that was straight and some hair that was like really curly. So imagine how weird that person might look like. But that's an example of codominance. The notation is what's the most important. So how do I notate red, roan, and white? I can't use capital R and capital W because that's the notation for incomplete dominance. So the next thing that I would show you is the notation for this. To be red, you have to be homozygous red. To be roan, you would be heterozygous. You get 1 red, 1 white. And to be white, you would be also the homozygous state for the white allele. Choose a letter that is of your favorite letters, except you should avoid X's, Y's, and I's. And I'll tell you why eventually. I'll choose C because that's my last name it starts with. So what you do is you do a base letter C, which really has nothing to do with the allele for red. You do a superscript. That's why you need this base letter, because you write it as a superscript. If you have red, that means you're homozygous. So I have 2 of the identical combinations, CR, CR. Notice it's still a capital letter, but it's written as a superscript. To be white, you still keep the base letter C. That stays consistent. But now I'm going to do a capital W and another C with a capital W. This is the notation. I don't control it. So you can pick whatever letter. It could be an F, it could be an A, a B. I don't care. It's not going to matter because you interpret what the superscript is. So what would be the roan? If it's got red and white, it means that it's got the C raised to the R and C raised to the W. It's the heterozygous state. Both of them show through. Imagine someone that has multiple color hairs, blonde and brown. That might be an example in your head of what codominance would be. If you have other ideas, come tomorrow to class and I'll let you know. Some people think like spots are. They're not technically, but spots, the idea is still codominant, where you have some patches that are white, like a Dalmatian. Some have black. In your head, if it helps you understand it, then imagine it's codominance. It's not technically, but you can still imagine it is. So if I were to do a cross, and I cross a red horse with a roan horse, it's CR, 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 CW. So I separate my red horse on the left, my roan horse on top. They combine. Do not do this. You cannot write it as CRR. That's not the notation. The C with the R is kind of one unit. So you would have to rewrite that second one. I've seen people do it. Don't do it. So you would have to write it as this, or CR, CW. CR, 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 CW. So genotypically it's a 2-to-2 ratio. Phenotypically it's also 2-to-2. 2 red to 2 roan. Alright? So that's codominance, and you'll do some examples with that. If you see something that has 3 phenotypes, but it's not a blending, that's codominance. If it's black, white, and black and white, if it's incomplete, black and white blend to be, to be gray. So say, for example, before I stop this portion of the video, if it says B is black and W is white, the notation warrants that this is gray because it's incomplete dominance. But if you see CB, CW, and you see this notation, it's not gray. It's black and white. It's an important thing to be able to decipher the notation. Alright, I'm going to pause that because I'm going to do the last one on a separate video.